We have two major objectives today. One is to derive the quadratic formula. And the quadratic formula can help you solve any quadratic equation. Unfortunately, it's not the most efficient way of solving. So if you notice the directions on the board about your homework tonight says factor, use quadratic formula. If you can factor by playing the game, it's far faster for you to do it. If you can factor because you recognize you have the difference of squares, it is far faster for you to do that. If you can factor because you see it's two terms and there's a GCMF, then factor, okay? If you notice you've got a quadratic term and a constant, isolate the quadratic term and take square roots, and that's faster. The quadratic formula are only for those problems where you can't play the game. There aren't factors that meet the condition. They're the kind of problems where the answer has the radicals in it. It's faster than completing the square, but it is by far not the fastest method. It's the only method that you can use in certain problems. It will work for every problem, but it'll take too long in the simpler problems. So we're going to derive the quadratic formula, and then we're going to use the quadratic formula. And I will point out one thing that those questions 16 and 38 are talking about. Quadratic formula. So this comes out of your textbook, out of lesson 13.4, so that's another good place to go and read. Okay, so we're going to start with the derivation of the quadratic formula, and I think we'll be okay to do it here. So what we're going to do is we're going to start with the generic form of a quadratic function. So ax squared plus bx plus c equals 0. So we remember our rules. Our rules say you cannot have a quadratic coefficient other than 1. Right now we have a. So first thing I'm going to do is divide everything by a. Oops. Excuse me. That gives you x squared plus b over ax plus c over a equals 0. We want to get the constant alone, so we're going to do opposite operations to get him alone. So we're going to subtract c over a from both sides. So we're left with x squared plus b over ax. Remember that x is either opposite the fraction bar or attached to the b, equals negative c over a. What's the next step? What do I do now? Justin?
B over a times 1/2?
Yep, we're going to take that linear coefficient, which is b over a, and we're going to take 1/2 of it. That gives me b over 2a. Then what? I'm going to square it, right? So b squared is b squared, 2a squared, 2 squared is 4, a squared is a squared. Now what I'm going to do is take that value and add it back to both sides. So I get x squared plus b over ax plus b squared over 4a squared equals negative c over a plus b squared over 4a squared. Now, you should notice that we can't combine over on the right side because they don't have the same denominator. So what I need to do is change negative c over a to a fraction that has 4a squared as the denominator. So what am I going to be multiplying top and bottom by on that negative c over a so that now I have 4a squared in the denominator? Molly.
4a.
Yeah, it's missing a 4 and it's missing an a. So I'm bring that up here. So now what I have on the left is x squared plus b over ax plus b squared over 4a squared. Now, what's weird that I don't like is I have a negative term, negative 4ac in front, so I don't like that. So I'm going to rearrange it and put the positive in front. So that means I'm going to have b squared minus 4ac all over the 4a squared. Okay. Now I'm ready to factor. So on the left side, I get the square root of x squared is x, then there's a plus. Square root of b squared over 4a squared is b over 2a, which again, that is exactly what we had when we cut our original linear coefficient in half. So this quantity is being squared, and then we have this b squared minus 4ac all over 4a squared. Now that I've isolated the squared term, I'm ready to take the square root of both sides. So square root. Now remember, there's really only one variable in this whole entire equation, even though you might say, well, no, that's not true. There's a lot of variables. There's only one real variable. What's the one real variable here? Patrick? Yeah, everything else is a number, and it's just holding the place of a number. The a, the b, the c, they're all numbers, okay? So the square root of a quantity squared is a quantity. So I get x plus b over 2a. On the other side, I get plus or minus, and I can't leave a fraction under the radical. So I have the square root of b squared minus 4ac, and then the square root of 4a squared is 2a. Last step is to get the x alone, so I'm going to subtract b over 2a from both sides. And what we've just come up with is the quadratic formula. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay? So here's one of the hard parts, is you're going to have to memorize this. So I'm going to help you memorize the formula using a song. But you are going to have to, the whole point behind deriving the quadratic formula should not be something that you have to memorize, because you just have to know how the process of completing the square. If you remember the process of completing the square, you're just going to perform it on this standard form equation with full of variables. Okay? So the process is no different that we performed here. We just didn't get numerical answers. Justin, you have a question?
Wait, why can't you find the square root of b squared?
Because b squared isn't b squared. B squared is part of b squared minus 4ac. So I can't take individual parts of binomials and take their square roots. It has to be something that they both share in common that has an exponent of 2, and it's a factor. Then I could take a square root of that. Okay. So how many of you know the song "Pop Goes the Weasel"? Okay. Dun 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 dun. Pop goes the weasel. Okay, that's the tune we're going to use to memorize the quadratic formula. Now be careful where you use this. I've had students who have applied to like a private school, and they had to take an entrance exam, and so he's taken the test, and he's, oh God, nothing. And he looked up and he said, everyone's staring at him, because he didn't realize he was humming the song out loud. So he's doing "Pop Goes the Weasel," and everyone's like, what is wrong with that dude? They let him in anyway, so. All right, so it goes like this. I'll do it once, and I apologize for my squeaky voice. X equals negative b plus or minus square root b squared minus 4ac all over 2a. That all over is really important because it goes underneath the negative b and the plus or minus and the square root of b squared minus 4ac. Okay, I'm going to do it one more time, and then you guys are going to join me. X equals negative b plus or minus square root b squared minus 4ac all over 2a. Okay, now you guys get to join me. Ready? X equals negative b plus or minus square root b squared minus 4ac all over 2a. Okay, that was probably the most pathetic attempt I've ever heard. Y'all need to sing a heck of a lot louder than that, okay? Okay, we'll do one more together, and then you're on your own. Okay, ready? 1, 2, 3. X equals negative b plus or minus square root b squared minus 4ac all over 2a. Okay, now remember, right now, because you're learning this, you can read it, okay? I'm seeing people like looking all over like, okay, I got to get it from my brain. It's like, dude, just look at it. It's okay. All right? This time it's all you. Nice and loud. 1, 2, 3.
X equals negative b plus or minus square root b squared minus 4ac all over 2a.
All right, very good. So hopefully that will help cement it in your brain. So now let's go ahead and let's use it. How does it work? So again, next week you're going to have a quiz. It's asking you to do this exact problem. There is no panic to sit there and I have to memorize the steps. I'm going to tell you right now, this is like a proof. And students in geometry class, those of them who try to memorize a proof that we've done in class that they think is going to be on a test, do not do well because they're missing what logically comes next. And so they don't remember the steps, and so they get stymied. They don't know what to do. The reality is you apply a process. And what's the next step in the process? What's the next step in the process? What's the next step? Jason.
So is that a formula? Is that what the answer should look like?
That's a formula. The answer's not going to have a whole bunch of variables in it.
Well,
So, well, that was the answer to your question.
So when we actually have the numbers...
Okay, why don't you watch as we do the next couple problems, and you'll see exactly what we're going to get, okay? So, the big problem that kids have with using the quadratic formula is this next little warning I'm going to give you. The quadratic formula was derived based on the fact that your equation was written in standard form. Ax squared plus bx plus c equals 0. So if your equation isn't written that way, then you're going to have an issue with solving, okay? So make sure equation is in descending degree order. On the left, and 0 on the right. Okay? So, first question. We have x squared plus 3x plus 2 equals 0. Now, just take this question for a moment. If we try to play the game, are there factors of 2 that would add to give us 3? Yes. So this actually, if this was a question on my homework for tonight, I would not use the quadratic formula. I would go ahead and play the game, come up with a factor, set the factor, put them in the binomial, set the factors equal to 0, and solve. But again, we're trying to practice with the quadratic formula, so I'm going to give you easy ones, and then I'm going to give you harder ones. So is it in descending degree order on the left, 0 on the right? So it's in our standard form. So now our job is to identify A, B, C, just like we've been practicing. So what's the A value? B value? C value? Now remember before when we were doing the axis of symmetry, we kind of ignored the C. We don't ignore the C anymore. Why? Because this is the quadratic formula. X equals negative B plus or minus square root B squared minus 4AC all over 2A. So now all I do is start substituting in the A values, the B values, and the C values. So I get x equals the negative of the B value 3 plus or minus the square root of the B value 3 squared minus 4 times the A value 1 times the C value 2 all over 2 times the A value 1. And then once I have that, I just keep solving. Keep doing math until there's nothing left to do. So I get negative 3 plus or minus the square root of 9 minus 8 over 2, which gives me x equals negative 3 plus or minus square root of 1 over 2, which gives me x equals negative 3 plus or minus 1 over 2. So now I need to solve for both answers. So I get x is either equal to negative 3 plus 1 over 2, or x is going to be equal to negative 3 minus 1 over 2. So we get x is negative 2 over 2, or x equals negative 1. We get x is equal to negative 4 over 2, or x is equal to negative 2. So my roots, my x-intercepts, my zeros for the quadratic function are negative 1 and negative 2. Now, let's just compare this for a moment if we'd played the game. So factors of 2 that add to give me 3 are positive 2 and positive 1. Because my quadratic coefficient was 1, I would have had x plus 2, x plus 1 equals 0. I would have taken each of those factors, set them equal to 0, and solved. Subtracting 2, I get x equals negative 2. Subtracting 1, I get x equals negative 1. So, purple or black? Okay, can you see the difference? That's why factoring is the best strategy if you can use it. If you can't use it, you've got the quadratic formula as your backup. Okay? All right, let's do another one. Let's give you one where it isn't so pretty. So the rest of the ones I'm going to give you are not, you couldn't factor through normal means, so you have no options. So this one we have 2n squared equals 5n minus 1. Is this in descending degree order with 0 on the other side? No. So here's something that's truly beautiful about quadratic formula. You know how when we were factoring, the quadratic coefficient was a negative and it messed you guys up, and so I said you can't have your quadratic coefficient be negative when you're trying to factor. When you're using the quadratic formula, not a problem. So what I can do is instead of getting everything to the left, I could just subtract 2n squared from both sides. Because the quadratic formula, all it cares about is what's a, what's b, what's c. So I'm going to rewrite that equation in descending degree order, and I get negative 2n squared plus 5n minus 1 equals 0. Once I do that, I'm ready to identify a, b, and c. What's a? Negative 2. B. C. And then I use quadratic formula. And remember, that's x equals negative b plus or minus square root b squared minus 4ac all over 2a. So in the beginning, repetition of writing something helps you memorize it. So we get x equals the negative of the b value, which is 5, plus or minus the square root of the b value 5 squared, minus 4 times the a value negative 2 times the c value negative 1, all over 2 times the a value negative 2. So I get x equals negative 5 plus or minus the square root of 25. 3 negatives make a negative. 25 minus 8 all over negative 4. So I get x equals negative 5 plus or minus the square root of 17 all over negative 4. Okay? Now, the only thing at this point, there's nothing really much I can do except for him. Really not a good idea to leave a negative in the denominator because we are not going to see it. So what we're going to do is distribute that, and we've talked about that before, distribute that back up to the top. So my final answer works out to be x equals positive 5 plus or minus the square root of 17 all over 4. And I would just put in parentheses the solution set notation, the 5 plus or minus square root of 17 over 4. I could do it that way or split them up. 5 plus square root of 17 over 4, 5 minus square root of 17 over 4. Okay? All right, let's do another one. I want to give you a variety. So, third one, we have a squared plus 4a equals 8. Okay, is this written in standard form? No, so we're going to have to get that taken care of first. I'm going to go ahead and subtract 8 from both sides. Everything on the left in descending degree order, and I get a squared plus 4a minus 8 equals 0. Now I identify my a, my b, my c. And this is why it's so important, folks, that you have the b value is the one attached to the linear term. The c value is the constant. Because if you misname them, your quadratic formula answer will not be correct. What's the a value?
1.
And the b value? 4. And the c value? Negative 8. So I'm going to launch right into quadratic formula. X equals the negative of the b value 4 plus or minus the square root of the b value 4 squared minus 4 times a, which is 1, times c, which is negative 8, all over 2 times the a value 1. And then I just start solving. So I get negative 4 plus or minus the square root of 16. 2 negatives make a positive, and 4 times 8 is 32, all over 2. And I get x is negative 4 plus or minus the square root of 48 over 2. Well, radical rules say you can't leave a perfect square factor under the radical. What's the greatest perfect square factor of 48, by the way? 16. So we're going to take the square root of each of those. When I do that, I get x equals negative 4 plus or minus square root of 16 is 4, and I can't take the square root of 3, all over 2. But that answer's not right. What's wrong with this answer? Patrick? Distribute is the wrong word. You're going to divide. So basically what you're going to do is look for a common factor and divide it out. So the 3 places you look are all exterior locations. And what I notice is they're all even. So what I'm going to do is divide a 2 out of each one of them. So I get x equals negative 4 divided by 2 is negative 2. Plus or minus 4 divided by 2 is 2. And then radical 3. And then 2 divided by itself is 1. And I don't leave 1 in the denominator. So my answer is either negative 2 plus or minus 2 radical 3, or negative 2 plus 2 radical 3, and negative 2 minus 2 radical 3. Okay. So we've dealt with the question where it all worked out. We've dealt with the question where it didn't work out and there was no simplifying. We've dealt with one where there was simplifying at the end. Let's deal with one more variation that could happen. We've got, bless you, 3y squared minus 2y plus 8 equals 0. Is this in descending degree order? Okay, that means we get to identify A, B, and C. What's A in this one? What's it? 3, and the B value? And the C value. Okay. So we're going to launch right into quadratic formula. X equals negative B. This is why it's so important to put your value in parentheses, because there's a negative outside, and the B value had a negative. Plus or minus square root B squared, so negative 2 quantity squared, minus 4A, 3C, 8, all over 2A. A is 3. Okay? And then keep going. So a negative times a negative is a positive. Negative 2 squared is a positive 4. And then we have minus 1 negative, so we have 12 times 8 is 96, all over 6. And we get x equals 2 plus or minus the square root of negative 92, all over 6. And we actually have a problem. What's the problem in this, where we're at, Serena? This is a mathematically, in our real number system, an impossible thing to do. So in the real number system, we can't go any further than this because we cannot take the square root of a negative. So what we say is there's no solution. So you can use the symbol there, you can say the words no solution. And the real answer is no solution in the real number system. Because you will find out in Algebra 2 how to take the square root of a negative. Okay? It's kind of an interesting thing. So those are all the varieties of things that you're going to come across. Now, I want to go flip back to the first screen. And on the final, the 2008 final, or 2013 final, I'm sorry, question 38 used the word discriminant. The discriminant is part of the quadratic formula. It's this part right here. Oops. It's the b squared minus 4 4ac. That's the discriminant, okay? b squared minus 4ac. Now, what you need to do is read in the book and figure out what's significant about that value, because that number that you get when you plug in b, a, and c into b squared minus 4ac will tell you, that resulting answer will tell you how many x-intercepts, how many roots, how many zeros your quadratic function has. How many times will it cross the x-axis? Twice? Once? Or not at all? Okay? I will demonstrate, just talking through. On number 1, there are 2 answers. I solved it and I had 2 answers, right? Number 2, there's going to be 2 answers. And we got 2 answers. 3, we have 2 answers. Again, my only focus is what's under the radical sign, b squared minus 4ac. So when I'm looking here, I'm only looking at 48. This one, it does not touch the x-axis at all. So if you're only looking at the b squared minus 4ac, what are you seeing with that number telling you if there's 2 answers, if there's no answer, and if there's 1? So if you just look in the book under discriminant, it will reveal that information, and that will help you answer 16 and 38 on the packet. Okay? All right, that's it.